If you want to look like a genius Python programmer, then here are 3 advanced features that you can start using today. This is not designed for beginners. These are complicated, but they're definitely interested in something that I'll break down for you in this short video. Feature number 1 is context managers. Now have a look at my screen here. I'm going to show you a few examples of built-in context managers, and then I'll show you how you can write your own. Now a context manager is simply when you use this with statement. So I say with, and then I have something that returns a context manager. We'll talk about that in 1 second. And then we perform some operation here inside of the indented block. So in this case, we're opening a particular file, and then we can write to the file. Now, when we use this with statement, we invoke a context manager, and what the context manager does is it has an enter and it has an exit operation. Now, the enter operation would be opening the file, and the exit operation would be closing the file. The reason why we use the context manager here is so that we don't forget to close the file afterwards, because if we were to not use the context manager and do something like file is equal to open, and then we were to write to it, so, file.write, whatever, manually afterwards, we would need to close the file. Now with the context manager, even if an error occurs inside of this indented block, the exit operation will still be called, so we safely know that we can deal with the file here and it will automatically be closed whether this operation works or it doesn't work. So that's all that it does. Now same thing here if we look at this threading example. We can create something like a lock, and then we can use this lock. When we use the lock, so with lock, the enter operation will be retrieving the lock or waiting for it to be open, and then the exit operation will be kind of releasing the lock and letting another thread use it. If you're unfamiliar with threads, don't worry, but the point is we use it here, and then again, we don't need to manually open or close the lock. It just happens with this context manager. Here's another one. We can use this suppress. So we say with suppress, file not found error. And what this means is we'll automatically handle any errors that occur in here and suppress them. So if this file doesn't exist, we won't get an exception. Lastly, we have something like using a temporary file. So we say with temporary file.temporary file, we create a new one. And then again, same thing, after this with statement, the temporary file will be automatically deleted. Now I know this might not be 100% clear, but I wanted to show you some built-in examples in Python. And now I'm going to show you an example of creating your own context manager, and you'll see how simple it is, yet how effective it can be for particular features. So here's an example of a custom context manager. Now the way that you write a context manager is you simply define a class, and then inside of that class, you have an __ enter and an __ exit, or a dunder enter or dunder exit method. Now the enter method is what's going to be called automatically by Python when you use this with statement. So as soon as this line is executed, line 16 here, automatically the enter will be called, and anything that we have inside of here will occur, and then it will be returned to the with. So sometimes you see something like with timer as timer. Well, this as timer will be equal to whatever's returned from this enter method. And you don't need to return something, it's optional, and in this case we don't use the return value. Then the exit method here is what's going to be called as soon as we exit the with statement, so we finish all of the execution, or if any error occurs. So inside of the exit method, we can print something out, we can end the timer, we can print what the elapsed time is, and in this example, I just wrote a simple timer that just times how long it takes for this operation to run. So let me execute this code and then we'll break it down even further. So you can see when I run this, it says starting timer, it then calculates the sum. We have this none printed out, which we'll talk about in 1 second, and then it says timer stopped, and this is the amount of time that it took to execute that code. Again, inside of the with, I didn't print anything. It simply started by running this enter, which is why we printed starting time. We then stored this value. We then printed the sum calculated, and then the exit got called where we printed this, and then we printed this. Okay, so context managers are extremely useful when you want to handle what's happening when you enter and when you exit, and make sure that you're always performing typically some cleanup or exiting type operation so that the code is always safe, you don't have memory leaks or anything along those lines. Now, something to note here is that if we were to have an exception, so we were to do something like 0/0, which will give us a 0 division error, what's going to happen is that exception is going to be passed to this exit dunder method in these 3 parameters. Okay, now exit will still be called, which is the important thing, before this exception actually gets raised and causes a crash in our program, and we'll be able to look at what that exception is by looking at the exception type, the exception value, and the exception traceback that we get passed as parameters. Okay, so let me run this and I'll show you what it looks like. So you can see here we get starting timer because we called the enter. We get now all of the errors that occurred inside of this exit dunder method, and then it says timer stopped, and then we actually get the raised exception here. Now we didn't print the sum calculated because we never made it to there because an exception occurred, but the exit function did get called before the exception was actually raised. So it gave us that opportunity to potentially handle this exception and make sure we clean up whatever we were doing inside of the context manager or inside of the with statement. Hopefully that's clear, but if you want to write a custom context manager, you define the enter and the exit, and then you can actually look at the exception type, exception value, and the traceback and do whatever you want with it inside of the exit function. So let's continue now with the next feature, which is metaclasses. However, I do want to share with you that the IDE that I'm using here, because a lot of you guys ask about this, is PyCharm. Now, if you want to be a professional Python developer and you do write a lot of code in Python, PyCharm really is just the best IDE that you can use. It has all kinds of built-in features that are really good specifically for working with frameworks like Flask, Django, FastAPI, and machine learning things like transformers, Hugging Face, etc. It even has integrations with databases. For example, you could just connect to one right here and view it. And it has all kinds of other features, like if you're working with a web app, you can actually just test the APIs directly from this IDE. And I've shown many of those features in various videos on this channel. Regardless, I do have a long-term partnership with PyCharm, so if you want to get a 3-month free trial of the PyCharm Professional Edition, which has all of the features you could possibly imagine, then click the link below and you'll get that extended free trial. Normally you get 1 month, but with my code you can get 3. You can try it out, see if you like it, and write some Python code. I promise you it's pretty cool and at least worth giving a shot. Anyways, let's get into the next feature, which are metaclasses. Now, metaclasses are famously kind of complicated in Python. A lot of people mix them up, and let me explain to you what these actually are. So to put it simply, a metaclass is a class that defines how another class is created. Now, to draw a comparison, if I create something like an object and I say obj is equal to an instance of my class and I give it a value like 3 or something, we would say that this class right here is kind of a blueprint. It's a definition of how we make an object, right? We're utilizing this class and we're creating an instance of the class or an object. So this class defines how the object is created, it defines its behavior, and we outlined it all inside of here. Now the exact same thing applies to classes. So when I create this class, we can have a metaclass that defines the blueprint on how the class is created. So rather than defining how the object is created, it's how the class itself is created. That's why we refer to it as metaclass, right? Because it's on top of the class, kind of defining how the creation of that class exists or changing particular functionality. Now, in order to create a metaclass, you simply inherit from type. Now, type is the base of every single class. It's what's used by default to create the class. I don't want to get into too many technical details here, and I'll leave a video on screen that goes into this much more in depth, but if you want to create a metaclass, you just have to inherit from type, okay? When you do that, you can now define different properties inside of the metaclass that define how a particular class is created. So what we've done is we've implemented this dunder new method. This dunder new method will be called whenever a child class is created using this as a metaclass. So when this class gets instantiated, when we create it, what happens is this new method is called, the class itself is passed as the class parameter, and then the name of the class is provided, the bases are provided. The bases is like anything that it inherits from. So if I had, class A and I was inheriting from that, that would be a base. And then we have a dictionary that contains all of the various properties and methods. Okay. So what I do inside of this new method is I say, okay, I'm going to create this new function called hello. This is going to be a method, and I want this method to belong to whatever class is being created with this metaclass. I know it's a little bit confusing, but don't worry. So I say hello from instance of self. I get the name of the class like this, so class.name, sorry. And then what I do is I specify a new property inside of this class that's being created called hello, which is equal to this hello method. Then I can return super.new. So I'm calling my base class's constructor, and then I can construct this new class and then return it. I know this is confusing, but let me show you something now. If I do something like object is equal to my class 2, and then I say object.hello, and I run this, let's go here, you see that it says hello from instance of my class. So now, anytime I create a class, if I want to use this metaclass, it will automatically add this property to the class for me. And we can use these metaclasses to do all kinds of advanced things and really control how various classes are created and behavior that all of these classes should have or should adhere to. Again, I have a much more advanced video that I'll put on screen, and I'm going to show you another example here that's a little bit more practical. So have a look at this plugin metaclass. What this does is it defines a registry, and this registry is going to keep track of all of the plugins that inherit from this metaclass, or that end up using this metaclass. So inside of the new dunder method, what we do is we create a new class. So we call our constructor, the parent constructor here, and then we say if we have any bases, so if we're inheriting from something, then what we're going to do is say the plugin meta dot registry, we're going to get the name of the class, and we're going to make that equal to the new class, so the new instance of the class that we created. Then we're going to print that we registered a particular plugin. So what we're doing inside of this plugin metaclass is we're just registering all of the concrete implementations of a plugin and storing them inside of here so that automatically we'll have a record of them, we'll be able to view them, and we don't need to manually register them later. So now what we do is we create a base class. This is an abstract class where we have a metaclass equal to the plugin meta, and we raise not implemented error. What that means is that this class is not meant to be used to create an instance of or to create an object from. It's meant to act as a base class for any other plugins that actually will have a concrete implementation. What we do then is we create an analytics plugin and a security plugin, and they inherit from this plugin class, which has this plugin metaclass. Because this metaclass is here on the base class, anytime these classes are created, this dunder new method is going to run. So when the dunder new method runs, if any of these classes have a base class, which these do, right? They have a plugin, what will happen is they'll get added to our registry. So we won't add this one because it doesn't have a base class, but we will add these ones. Then we'll be able to look at the registry from our metaclass right here and print out all of the plugins that we have. We then could actually use the plugins by looping through all of the items and creating a new instance of these classes. Let me show you what I mean. Again, I appreciate that this is some complex code, but that's the point of this video. Okay, so you can see that what happened here, if we look at our driver code, is that when we created the analytics plugin, so when we actually defined this class, it was registered as a plugin. That happened inside of our plugin meta, right? Then same thing for the security plugin, it was registered, and then we print out here the available plugins, and you see that we have the name of the class, and then we have actually a reference to the class itself. Then what we can do is we can use these class references to create an instance, so we instantiate it, and then we run the run method, and then same thing for the security plugin. Okay, so that was it for metaclasses. Now we're moving on to generic functions using something called the single dispatch. Now, before I get into that, I want to show you an example of some code that doesn't use this feature so you can see the advantage when we go over to that. So oftentimes in Python, we're going to have functions that will work differently based on the type of various parameters. So in this case, we have some object, but maybe the object's a number, or maybe the object's a string, or a list, or something like a dictionary. And based on what it is, we're probably going to do something different, right? So if the type of object here is an int, then what we're going to do is print, okay, this is an integer. If it's a string, we're going to print this is a string. If it's a list, we're going to print out maybe the length of the list and the number of objects that it has. And if it's something like a dictionary, then same thing, we'll print out, what is the length of the dictionary, and then maybe all of the various keys. And if it's not any of these, we can say, okay, well, we haven't implemented this, specific functionality. And this is quite common, and you have, because we're working in a dynamically typed programming language, just a lot of instances where you could be expecting various different types. Now, there's nothing wrong with the approach that I'm showing you here, but there is something built into Python that allows you to create what's known as a generic version of a function. This is something that will essentially allow you to call a different function with the exact same name based on the type of the parameter. So let me just show you what I mean, and you'll see. Okay, so here is the exact example that I wanted to show you, feature 3. So I say from functools, import single dispatch. Now this is a decorator that you can put on top of some kind of function. So in this case, we defined a describe function, we decorated it with single dispatch, and then we just said, okay, we're gonna raise the not implemented error, and this will be kind of the fallback or the backup implementation of our particular function. Then below this, we write 4 functions that have a concrete implementation based on the type of the first parameter. I know this is weird, just bear with me. So we have an object, and if the object is of type int, and we call the describe function, we're gonna run this implementation, the one that starts with an underscore. I know, again, it looks weird. Same thing with this. If the object is of type string, then we're gonna run this function right here because it's registered to this describe function name. Same thing if it's a list, then we're gonna run this. Same thing if it's a dictionary, then we're gonna run this. So you can see we have the same kind of driver code that we had before. And if I run this code using the single dispatch, you can see that we call the appropriate function based on the type of our first parameter or of our first argument, whatever you want to refer to it as. So again, what you can do is you can define this function, you give it a name, something like describe. You decorate it with single dispatch, and then what this allows you to do is register various other functions here where you specify that you want the function to have the exact same name. It's going to take the exact same parameter, but if the parameter is of type int, then you execute this implementation. If it's string, then you do this implementation. If it's dict, then you do this implementation, and it avoids you having to do this kind of pattern where you're doing all of these if statement checks. Now, there's advantages and disadvantages of this, but it allows you to create what's known as a generic function that can handle various different types of data and to separate all of those implementations into separate functions, which can be a little bit easier to understand and to add various different implementations of. This, in my opinion, is cleaner and a better practice. It's easier to understand than if you were to write, 100 of these is instances and really just make this function like super messy with a ton of different if statements at the very beginning. Now, let me show you a bit more of a practical example so you can see when we would actually use this. Okay, so here's an example of something you probably want to do. You want to typically serialize data in Python and convert it from a Python data type to something like JSON, especially if you're working with maybe an API. Now, not all types in Python can be serialized. Serialized means essentially you can convert it from a Python type, like a string, a number, whatever, to a valid JSON type. Something like an object here, like a user object, we can't serialize this by default. We need to write something custom to do that. So what I can do is I can write this toSerializable function. Now, by default, we're just going to raise a type error, and we just write this function as kind of like a fallback, right? Something that we will run if we don't have a supported type. So we have at single dispatch decorated here. Now we can use this function name and we can register various implementations with the same name. So I'm going to say toSerializable.register, and now I'm going to show how I can serialize a date-time object. So if I have a date-time object, what I'm going to do is I'm just going to return the ISO format. If I have a set, for example, which by default is not serializable, then we'll convert it to a list. And if I have a user object, then I'll do this. I'll make my own custom JSON where I have a name, an age, and a join date, and I'll do the serialization myself. Now, the advantage of this is now I create this data. I have something like a user, a dictionary, a created at, and rather than having to call 3 different functions to serialize this type and do all kinds of checks, I can just use something like the built-in json.dumps function. I can pass my data, and as the serializer, I pass my serializer function. And because this function has the same name and it will automatically pick what implementation to do based on the type, we'll now be able to serialize this data because what will happen is behind the scenes, this function will call the serializer on all 3 of these types in these fields. So it will use the serializer function, it will take the correct implementation, and then it will serialize it for us. So let me run the code here. And you can see that we now get our serialized data type that we now can return as valid JSON. I understand that finding practical use cases of this can be a little bit difficult. It is a more advanced feature, and the point of this video was to show you some more obscure things and just kind of get you thinking about what Python's actually capable of doing. If you're something like a vibe coder, you would never know what something like this does unless you watched a video here. So I'm trying to do some more advanced topics for you guys and kind of keep some stuff interesting on the channel. If you found this video interesting, then make sure you leave a like, subscribe to the channel, and I will see you in the next one.